What is going on, everybody? Welcome back to another video of Cup of Code 01. Today we're going to be rocking out the beginning of, in this 100 Days of Python, NumPy. So NumPy is a library, a very famous library, just like pandas, that exists for Python. NumPy is huge at manipulating mathematical matrices, arrays, vectors, reorganizing data in ways that is way more appropriate for computers to utilize. NumPy you need it. You need the darn thing. End of story. So we're going to be learning NumPy. It's also very helpful when we're trying to understand certain mathematical principles when it comes to machine learning, deep learning. Now, when we do those kind of tutorials, we are not hitting heavy into the math by any means. Sometimes I introduce it, sometimes I don't. Most times I don't. It's not important that you understand how to do it, but it is important to understand when you're doing something like backpropagation to have an idea of what the computer's doing. Because again, everything I'm trying to encapsulate is what is the computer doing? How is it seeing what I'm typing? How is it converting what I'm typing into usable code for the computer? And then how is it manipulating the data that I'm applying that to give me feedback, to give me output? And then when I'm running things as complicated as like convolutional neural nets or recurrence or adversarial networks, what is the computer actually doing? That's always my question, is what is it actually doing? And so understanding that is a huge mountain of information. But one of those primary boulders is things like NumPy, pandas, different kind of data frame analysis, different mathematical operations, and utilizing it to change up vectors or arrays, matrices that we deal with. So I figured what better way to start a lot of our machine learning work and artificial intelligence work than to utilize NumPys in 100 Days of Python. So let's start off with something simple. What version of NumPy do you have? So all we're going to do, I'm importing NumPy's NP. That's kind of a process you'll see everybody doing online. And I'm printing NP, that's calling it. So by printing NP, we're calling the NumPy library that we imported. Dot __ version __, everything in the print function parentheses. I'm going to execute this in the console, and I'm going to make this a floating window so that it is a little bit cleaner. Let me go up. All right, so we ran our code, import NumPy, print version, it printed out 1.12.1. If you don't have it and you don't know how to load NumPy, let me know. There's so many videos. I utilize, before I downloaded PyCharm, I download Anaconda, and even on my virtual machines, I do the same thing. I'll have to make a video on the virtual machines that I use as well. I'm even changing up my entire system. I'm creating my home desktop into a server where I can run virtual machines, because since Python is single-threaded for the most part, single core, and a lot of software, games, a lot of major software, coding software, is not utilizing all these cores. So if someone buys a processor with 10 cores, they're not using the damn things. So I thought it was a hell of a lot better. I find it a lot better if I have, I do have a 6-core machine right now, and I'm going to probably get the 18-core i9 that comes out, or I'll mess with Threadripper, or I'll mess with the Xeon. But I am changing my system to a server base because I can open up 3 virtual machines that are using different cores on the processor. They can all run the same code at the same time with slightly different variables, and they can also all have their own GPU, utilizing something like Unraid, where the GPUs can actually pass through. Because if you're using virtual machines like VMware, your GPU, your physical GPU cannot be used by the virtual machine, but doing something like an Unraid system, it can pass through. So with that being said, each of these 3 different machines I have, all my physical one machine, are all running the same code but different variables. I'm running 3 neural networks at the same time. So what something used to take 8 hours to do, now I'm getting 3 different outputs from that, so I can maximize variables a hell of a lot faster than, say, doing something like grid search when I was doing neural nets. So I'll have to do a video on that at some time in the future as well. I'm still toying with the idea of what processor I want to go for this next build, but we'll play with that. So NumPy, and if you don't have it, let me know, and I'll show you how you can import the bad boy, but it's not too complicated. So that was the first challenge. What version of NumPy do you have? Next challenge, convert a list of numbers into a one-dimensional array. Again, NP stands for NumPy. So a one-dimensional array. One dimension, just think of it as like one row or one column. There's only one dimension. There's only one piece to it. Either it's a Y vector, or it's an X vector, or it's a Z vector, but it's only one dimension. So in our example here, we have a list. I'm creating a variable list, and I'm just passing through that list some variables. I'm putting some integers and I'm putting some floats, but just a list of numbers, nothing crazy. Then I'm typing a string to print with a space, comma, list. So with my output, better say starting list, and it's going to give me a list. So this is the list that we're doing. So let's execute that in code. So here's my list, nothing fancy. I didn't do anything crazy. All I did so far was add a string to a list that we had, right? Wow, complicated. Now we're going to do our 1D array. So I'm creating an object named 1D array, and it equals np.array. So I'm calling this method of this function, the array method of np. So np.array, and then open and close parentheses, and I'm going to pass the arguments that we need. Now, people always ask, how the hell do you learn different things if you didn't have tutorials or if you didn't have books? And the way is always the documentation. If I went into NumPy documentation, I looked up arrays, it would tell me what kind of arguments I have to have and what kind of arguments I can have. So in this one, I'm actually going to take this out just for right now, and I'll show you what I mean. So let's say I just had this. We had np.array list. So it's going to take the list that we have here, and it's going to apply the np.array function to that list. I'm printing my first one-dimensional array, which is a string, comma, give me the value of the object 1D array that we created. So I'm going to, I'm going to put this into the console, and my output is my first one-dimensional array. And now we no longer have these numbers that we have up here. We now have them like this, which is not fun, but I'm going to show you how we can change that in a hot second. And you might say, what's the difference between a list and a 1D array? Let me actually do that now. I'm going to put a new argument in that I took out. All this is d type, data type equals integer. So now we're telling Python, for this one-dimensional array, I only want you to be, I want them to be back to back. I only want you to be an integer. I also could have done it on the list if I wanted to. So our starting list is here, and now our first one-dimensional array is here. Notice how the commas are gone. Notice how the floating number is gone because now it's an integer, 45, and it does not round. 0.7, you think it'd be 46? Not, just cuts it off. Same thing as 0.6, it's going to be 0. Better be, yep, because it does not round. It's just going to cut it off. But the difference is a list, we have open and close brackets, just like the array. The commas are gone. Now this is a one-dimensional vector in space. We don't have any other dimensions to it. Now this might seem it might seem stupid to you right now, and like, what the hell's the point of that? Oh, why, you move commas, congratulations. But if we wanted to do certain mathematical operations, run different algorithms like we're going to later, well, you can't run it on a list, but you can run it on an array. So we're just making the computer happier with what we're giving it. Let's go down to the next challenge. All right, next challenge. 3x3 matrix, which is a rectangular array. These are just words you're going to hear a lot as we do more advanced stuff. But if we have a matrix is just a rectangular array, array is a multitude of different dimensions depending on what it is, but it could be a row or a column array. But matrix is a rectangular array with values of ranges 2 to 10. So numpy.arange is what we're going to be using. It's not a range, it's not ARR-ANG. If you try to do that, you're going to get, it's going to come back and say a range not, what the hell is this? It's not defined, range not defined. But this is, if I went into NumPy's documentation, this is what it's going to tell me a range is. That we have a start, we have a stop, and we have a step. And data type, we can put in none, or we can put in integer or float, whatever we wanted to do. Start, stop, and step. So start and stop, I gave you that in the challenge, a 2 and a 10. So start at 2, go to 10. So again, we're not going to include the 10. I mean, if I want 10, I have to go up one more because, again, the range cuts off. It does not go to that actual number. It goes to the place. And when we index, we start at 0. So when we're counting, so at number 2 would actually be indexed to 0. And 10 here would be indexed at 9. So if I want the number 10, I need to index it for an 11 on that range. And then step. Step is how many, exactly that. So a step is how many places do you want in between your numbers. So if we just did 2 to 10, we're going to get 2, 3, 4, 5, 6, 7, 8, 9, 10. If I do 2 to 10 with a step of 2, it's going to go 2, 4, 6, 8, 10 because we're taking a step of 2 in between. So I'll show you some of those variances right now. So we have a variable x or an object x equals np.arange 2, 11, that's our start and stop. Again, the 11, because I want the number 10, and the way we index on range, it wouldn't give me that if I did 2, 10. So I have to do 2, 11. Dot reshape 3, 3. So the dot reshape is simply the method we're applying to this NP that we're creating, this NP.arrange. 3, 3 is the matrix that I want, 3 rows and 3 columns. And it's going to put those into brackets because it is going to be a vector. So, and then I want to print that. So let's do that. Let's run it, execute in the console. So my output here we have 2, 3, 4, 5, 6, 7, 8, 9, 10. So do I have a range 2 to 10? I absolutely do. Do I have a 3 by 3 matrix? I absolutely do. This is a 2-dimensional array because you have Y's and we have X's, or we have rows and columns. So these are 2 dimensions because each number, each item within these 3 individual vectors, or within this matrix, each one of these values in the matrix has a 2-point system for its dimensionality. It has a row and a column dimension. So if I take the 6, that doesn't mean anything to me. I can't just say column 0, 1, number 1, because, well, I don't know, what row is it in? Is it in row 0, row 1, or row 2? So that's why it's a 2-dimensional piece here. But this is a 3 by 3 vector because we have 3 rows and 3 columns. And that was the reshape function did. You can see we have our brackets. We have the brackets on the outside saying it's an array, and then we have the 3 on the inside for each of the individual vectors that are making up our matrix. Now here I have 2, 10 spacing of 2, and you're going to say, why don't you have the reshape? And that'll make sense to you when I run it. So I'm going to put it in console. So on that code that we just ran, which was np.arrange 2, 11. So start at 2, print out 10, but go to 11, index of 10, and give me a step of 2. Print y, so 2, 4, 6, 8, 10. Why is it a 1-dimensional array at this point? And that is simply because we can't do a reshape, a 3 by 3 reshape, if we don't have enough values. So we have 3, 6, 9 values within this 2 to 10 range, correct? Here we have 1, 2, 3, 4, 5. So I can't do a 3 by 3 because it can't give me an empty space. It will give me an error. But if I sit there and if I said, give me we could do 1, 2, 3, 4, 5. If I made this a 6, let's say we went to 12, start in step 12, step at 2. Now I could do a dot reshape and make it a 2 by 2 matrix if I want, because now I'll have enough numbers. Now I'll have a number. Oh, I only give it 5. Why did I do 5 arguments? So stupid. Well, that's a good error. That's a good error to see here. So again, for me doing 2, 12 step by 2, I was creating 1, 2, 3, 4, 5. See, we're going step 2. I made my own mistake. I need the number 12, so I got to go 13. So that I could have 1, 2, 3, 4, 5, 6 values. If I'm doing a 2 by 2, that's only going to give me 4. I'm going to have to reshape it differently. But it's telling me here that I cannot reshape an array of size 5 into shape 2 by 2, so they have to match. So if I'm going to have 6 values, I could, if I wanted to, I could keep it, I could have reshaped it as 3 by 3, 3 by 2, I mean, because we're going to have 6 numbers. Execute in console. So now I have 2, 4, 6, 8, 10, 12. So now I have a 3 by 2. I could have done it in different as a 2 by 3, which is different because it always does it as row column. So now I have 2 rows, 3 columns. I have 2 rows and I have 3 columns. We're not going to get fancy now with transposing them rather, but it's good to start to play with these matrices and understand how they're created and how the computer is going to see them so that it can make more sense when we utilize different math and different properties later on. But now that I had the proper numbers, the proper calls for it, then we could reshape it. Otherwise, you'll get that error. I'm glad we got that. Otherwise, you'll get an error here. And it tells you, you can't reshape an array of size 5, meaning if you only got 5 numbers, you can't fit it into a 2 by 2 matrix. You need at least 4 numbers for that, right? Or 6 numbers for that. 1, 2, 3, 4. Oh, 4 numbers for that. So if I did it as, if I put 4 numbers in, meaning if I kept it, if I brought it down, so 1, 2, 3, 4, 5. So if I went from, instead of 2 to 11, if I went from 2 to 10, I would have had 1, 2, 3, 4 numbers. Then I could have done then it would have given me a 2 by 2, because then it would have set a size of 4 into a 2 by 2. That would have made sense. But with 5, it's not going to work. And then when I went from range 11 to 12, the reason it still didn't work at 12 is because it was not going to print 12 because it cuts off as 12, and we did a step of 2. So by going up to 12, it needed a step of 2 at that moment, which was going to be 11. So it gave me an error at that point because it can't do that. It's not going to print 11 because that's not a step of 2. But when I go to 13, which is what I did here, now it will print the number 12 because, again, at 13 we cut off, and it was a step of 2. So I fulfilled all the criteria, if you will. All right, next example. Create a null vector. A null vector is going to be all zeros of size 10, and change the value of 3 and 6. Let me just quickly go to View, Active Error, and put in soft wraps. And change the value of 3 and 6 position. So change the value of the zeros that are in position 3 and 6, because that positioning is going to obviously mean indexing. So x equals np.zeros. How many zeros do I want? Oh, look at that, I just changed it. Haha! I want 10 zeros. We can make this integers by simply just doing int if we want. I put that there as a reason to show you. Let me or you could do data type int. I'll put that back in a second. Print x, so if we do this alone, print x, so I got 0 dot 0 dot 0 dot. Now normally you sit there and say, okay, fine, I want integers. This can actually become a problem when we get into certain machine learning properties, turning about rank arrays, but we'll cover that at a different time. So if I did this as int, that's kind of a dirty way to do it. It's going to give me all zeros as an integer, and I'm willing to bet we could also do, because it is NumPy, even that way of doing int had better give me the same thing, and it certainly does. So I have an NP array of 10 zeros, and these are integer. It just looks better than having the zeros, and it comes into something called rank arrays, which we'll cover a different time. Next line, x. I'm going to be indexing. So I'm saying x is going to be, I'm indexing 3 different positions. So it's going to be an index of an index essentially, or an index of an array rather. So the first two, these brackets are saying I want to call an array. I'm calling the array x, which is up top, and I'm calling an index of 2 different positions. So I need more brackets. If it was just one position, I'll show you, I wouldn't need those 2 brackets, but I am calling 2. So I'm calling position 3 and position 6, or index position 3 and index position 6. So let's look at that. So we have 0, 1, 2, 3, 4, 5, 6. So that one and this one, we're trying to isolate to change, equals 21. So in those 2 positions I showed you, 0, 1, 2, 3, and here, change those zeros into the number 21, print the x. Let's see if it works. Execute in console. And sure enough, we changed index position 3 and index position 6. We changed the values of that. Again, it may not seem cool and useful now, but it will later on when we get into different applications of NumPy. Now, what I was saying before is if you did this, then I would have only needed 1 bracket, execute in console, because I'm only calling up 1 index position. But when I'm calling multiples, if we tried to do comma 6 here, it's not going to make sense because now you're saying it doesn't know that you're asking for an index is what the problem here. Oh, I didn't get the whole thing. That was my fault, sorry. Too many indices for array. Wait, no, that's not even it either. Why is it not doing this? Well, hold on, guys. Let me close that. Let me go back to this. Let me do execute in console. It's not even running the rest of the code here. It's not seeing that last piece there, which it's obviously there. But normally when you do indexing, you can't have, even if I do the comma, I don't know if you can see it. See how it's giving me that error there? It's missing a white space. That's just using SPEP. It's making things pretty. Now that goes away. But it's still not going to do, it's going to keep giving me errors. It's going to keep giving me errors. And again, it's all because of the fact that I have this syntax wrong. So if I have, I want the array x, and if I'm calling 2 positions, I need to index as such. And now I will have no problems whatsoever. So there we go. Now I changed my 2 index positions again. Everyone's happy again. Let's go down the list. I'll even do that to get rid of that error, or rather the PEP8 recommendation. So lastly, I have create an array and reverse it. Can you hear that and not think of the song? So create an array and reverse it. And this looked familiar to you if the function video was loaded first, because I did show you this was an alternative way to reverse something. And this time we're going to reverse an array. So x equals np.arange 7, 21. So again, a range is going to simply be a range of the numbers that we're putting in. I should make that a shortcut key. So here we have, I don't like how it's doing that. Hang on. I'm going to rerun the console. And now I want to do that. Oh, see what happens. Let me show you what happened. I reset. This is like resetting a kernel. And then the error it gave me, it says, hey man, you're calling NP, but you never defined it, which means it doesn't see the import, which makes sense because when I reversed it, when I restart the kernel, I got rid of this, import NumPy as NP. It got rid of that from memory. So all I'd have to do down here, I could run that again, or we can just say fine. Don't know why I did that. So now, of course, it's going to be happy because we imported NumPy, and now it's going to run the code. So what it did was, oh damn, I didn't want to run that part yet. I apologize, guys. I just want to first show you the first part, creating the np.arange 7 to 21. So again, we're not going to have the number 21, which we don't. It's cutting off what we're going to have that many positions. So starting at 7 and going up to 21, but not including 21. So we have all of those numbers. We created a one-dimensional array using np.arange. And that could have been anything you wanted. We printed it out on the console. Now, what this code here is saying is take the array you just created, which we have here, equals x, where I'm changing what the object x is going to be. It was this np range 7 to 20. And I'm saying start this colon means we're indexing essentially the beginning and the end of the list. That's what we're going to be doing. So colon is the beginning, and then again means to the end. So go all the way from the beginning to all the way from 7 to 20. Minus 1 means reverse it. So right now, whatever's in this index, make that index 0. And this in this first index 0 is going to be the last index, and just reverse it. So it's kind of like, think of it this way. The computer's going to go, all right, I have the array x. I'm going to go from the beginning to the end, and now reverse it. 20, 19, 18, 17, 16. That's what it's doing here. So when we run this code, that's what we get. Take that array from the beginning to the end and give it to me in reverse. That's all it did. All right, guys, nothing too crazy today, but a good introduction to NumPy. I know a lot of the stuff is going to seem like, why do I need this? This seems stupid. I want to go to the projects. But this is all foundational work that you're going to be doing as we get into the projects. And I am working on 3 different projects at the moment that are not machine learning, AI, deep learning integrated, but they're just fun projects, again, just to learn more Python, to understand better with functions and loops and how things are communicating with each other within scripts and even between different scripts, how everything is rocking and rolling. So with that said, I hope you guys have an excellent day and enjoy the rest of your week.